So we're going to talk about power calculation. Power analysis is the calculation used to estimate the minimum sample size necessary to enroll in a study to demonstrate a statistically significant effect. It's an important element to estimate in planning a study, especially in RCT. How many people will we need to recruit? So the elements that are considered in power calculations are, 1, the desired power. Most people consider power of 80% or 90% to be necessary. The statistical test that we're going to be using, the level of significance, we've talked elsewhere that this is traditionally alpha less than 0.05, and then the effect size. The effect size is an estimate of the expected clinically meaningful or practically important difference in the parameter of interest. And I've included an example that if a new diabetes drug was being tested against a gold standard, I would need to see a reduction in A1C of, say, 2% from an average of 9.0 to 7.0 to be impressed that the new diabetes drug is actually better than the gold standard. So we can see in the diagram that sample size is on the bottom, power is on the top, and it's not a linear curve in terms of sample size increasing and conversely power increasing as well. Many clinicians will seek statistician help or will use a computer app to help them determine sample size. An RCT may only need small numbers in each arm to demonstrate a statistically significant difference if a relatively large effect size is expected. So don't criticize an RCT for small numbers when it's actually been adequately powered to demonstrate an effect.